Hello everyone, and today we have a Repair 1080 Mini graphic card. The story about this graphic card is unknown because I would guess bought this card from eBay in a broken condition and was rejected when he was trying to return it under the warranty. Before we start doing our repair process and diagnostic, let's just have a couple words about this graphic card. We usually don't recommend those graphic cards, and I actually have on me other graphic card in a mini solution. This is a 1070 Ti, and those graphic cards we call them hot potatoes, because they are in the size of a potato, and those cards getting really hot, not just in the area of a GPU, the whole card is getting hot. Even just think about it, those cards, they have same specifications, same characteristics as the reference cards, and decreasing them in size eventually will increase the temperature on a card in general. Therefore, what we usually recommend if you eventually ending up buying this graphic card, getting this graphic card, we are recommending thinking and a smart thinking of a cooling system of your tower in general. So it cools down, this graphic card cools down not just with this little fan and a smaller radiator, but also cools down by a cooling system of your tower. That's it for now. Let's plug it in and confirm our problem. Plug in our card. Oh, this one is 8-pin connector, our post card, and the screen. Okay. Looks like everything plugged in. Just double check. Yep, good to go. "13 to A to E." Now we can see our card got detected, but doesn't bypass our BIOS postcode to E. And the fan is spinning, but there's nothing on the screen. So far what I could tell that we do have our main powers, but we don't have, or partially don't have, the power to our chip. So let's open it up and have a closer look. Okay, now let's see how our card is acting up. Our chip is slightly getting warm, but in a range of safety for it. So let's start from our main powers, and 12 volt from our PCI Express connector, we have it, and from our power connector we also have it. Next, let's come down to our 5 volt phase, and good. 3.3 volts is better measure up on the power to our driver, and that's present. Let's just really quick have a peek on the power to our BIOS flash, which should be 1.8 volt. Okie dokie. Next, chip is a little bit warmed up. Let's just give it a little bit time to chill it out. Okay, let's now see power to our chip. Straight and forward, let's see our main power, and here we go. Nothingness. Let's see power to our memory, and we don't have to be scared that instead of 1.5 we have 1.3, because this is a GDDR5X. This is relatively pretty much new memory, if my memory not mistaken. They started producing them from 2016, and this memory is better in the 3 ways. First one is capacity is increased. The second is data transfer in it twice bigger. It has 1314 gigabit per second in compare with the 7.8 on a GDDR5, and also energy saving been increased. Instead of 1.5 volts, that's what we are having right now at 1.3. So we have perfect power on the memory phase. Next, let's see our PCI Express 1 volt also present, and our loop phase 1.8. Awesome. So what it looks like, we only want power which we are missing is a power to our GPU. And now let's see our resistance on our card, so we are sure that we are not dealing with a short or lower resistance. And let's start from our chip. Our memory, let's start from our memory. Our power to our memory is a two-phased, and it doesn't matter on what phase we will measure it up, because those phases are in a parallel. And is 104 ohms, which is perfect for those graphic cards and with this memory. On our PCI Express, we have 83 ohms, which is perfect. Also, we will check the resistance on our chip, but we won't be able to tell a lot by this resistance, because resistance for those chips, it's not supposed to be high. But I already checked that with the power supply behind the camera, and I already showed in one video how do I do that, and our power supply doesn't go into defender mode, so we are given about 90% that our chip is in a working condition, is good. Next, what we will check is also behind there we have one phase, which is our loop, and give me a second. Okay. And we have here perfect, about a kilo. Of course, first what comes to the mind to check is our DRMOS. That's in 50-60% of the case we are dealing with when we have issues, power issues to our GPU. As we know, our DRMOS contains 2 transistors, top and a bottom shoulder. And the top shoulder we will be checking on a 6-pin, that's our gate high. Our source is located on a signal switch node, which is from 29th pin to our 35th pin, that's a source for our top shoulder. Bottom shoulder we will be checking on a gate low 36 pin, and anywhere where we will be able to find, and the source is located anywhere where we will be able to find the ground. That's about resistance. About powers, actually half of the powers we already have checked, such as that's a 12 volt line, and that's where our GPU takes a current, and it's present VDRV, that's a 5 volt line, and it powers up our driver. VC, and also 5 volt line, also powers up our driver, but it powers up a logical part of it. What signals we will be going through is disable. It basically enables our DRMOS, and we should have a high level over here. Is a S mode. It controls our lower shoulder, and a PWM. On the PWM, the way basically how it works, on a disable and S mode we should have a high level, and on a PWM we should have already a beautiful impulses, which are basically a data transfer from our main controller. Okay, and yeah, I just probably saw somewhere. That's as far as I'm knowing how it works. And here we can see a table, basically how we disable S mode, a high level, and by 3 states of a PWM we're already controlling our keys. Okay, let's start from our top shoulders, and the first key. Here we're good. Same value, good. Okay, top shoulders looks like alive. Let's then keep measuring our lower shoulders. That will be a little bit easier. First one is good. Okay, this one is good. Good. Okay. Resistance didn't really show us a lot, and I also a little bit went over our DR MOSes, and nothing so far could be found. Therefore, we will proceed measuring our powers, and if we eventually end up measuring our PWM pin, it's better doing it with the oscilloscope, and that's why we brought it down. Okay, let's start from our enable. Just give me a little bit time. I want to hit the right pin. Okay, and we have a high level. Let's check our S mode. And on S mode we have a beautiful high level. So our driver is in a ready condition, and now let's see what kind of impulses he gets. Okay, let me just catch it up. How we can see our driver gets some bunch of impulses, but this is more looks like a gibberish. Of course our driver can be controlled by it, because how we can see at least amplitude for this impulses is about 20-30 millivolts. Unfortunately, after all our measurings, what it looks like, we are looking for our problem not in the right place. I actually was hoping that we would have a problem with one of our DR MOSes, because there's nothing specific about them. This is the 6788, and those and similar to them I've seen on multiple other graphic cards starting from 780s. Also, I'd like to say there is no guarantee that we will be able to fix this graphic card due to not having a schematic or any other diagram, and I actually might apply right now to the most common asked question, which is sharing schematics. Schematics for graphic cards are available only for authorized repair stores, which I'm not. I don't even work right now at any repair store. I used to work in a small repair shops. Only one time I tried to apply to a huge one, if I'm saying the name right. It was the Lewis Rosman. And I gotta admit, I've never seen his or any other English repair channels. I just heard that he is good, and I tried to apply to him. I came down, I talked to him, he said that I'm good, took my number, but never gave me a call back. Due to my experience, I don't possess any datasheets for those graphic cards. The next our step is will be see our main controller. That's where we are getting our PWM, and I already got a datasheet for this controller. There's actually lots of pins which we have to go through, but we will start from as simply as step by step. First step is measuring our power. Our controller gets power from a 5-volt line on a 12 pin. And we have 4.2 volts. And that's not, it's not supposed to be lower than 5 volts. Well, in this case, having a schematic would really help us track our problem. How we could already make sure we have a 5 volt. 5 volt is present on our graphic card, but to our controller we get only 4.2 volts. Everything what we can do is have a look on our datasheet for our controller, and on our next page is located a typical application circuit. That's basically how our controller usually applies in a circuit, and how we can see is a power pin gets connected to a power circuit through a resistor. And if we go to a pin description, it says that 12 pin 5 VCC supply input for the IC. Connect this pin to a 5 voltage source with a 2.2 resistor and 1 microfarad filter. I do not know how it's seen on the camera, but thankfully our 12 pin is kind of visible. The track of it is kind of visible, and this track is a continuity for this 12 pin, and it leads to what it looks like. This is our 1 microfarad filter, and this is our resistor what we are interested in. And now let's see a resistance for this resistor, which we have 2.2 ohms, and we have about 2 kilo ohms resistor. Okay, and now let's put our card into our test stand, plug in our screen, power. What I'm gonna do, I'm gonna just jump over resistor with the tweezers. I'm taking the whole responsibility on myself. Of course, I do not recommend doing it, because that might lead to burning our controller, or in a worst case scenario, the whole graphic card itself. But I don't have explanation why I still want to jump it. Let it be experience for us. let's just see that our card still does the same and not giving us any image. Yep, same. Under the warranty, and this is my conversation with the owner of this graphic card. Anyway, got the GTX 1080 back from Gigabyte finally, previous, and I can just explain what happened. In compared with the Apple Store, which they just verbally tell you the reason why they don't want to swap your device, or they just basically tell you no. With the graphic card, they actually send the new card back with the pointing area with which under which they can replace your card under the warranty. So this area, it was over here. So this is it. When I got it, was two stickers over here, but to be honest, it looked just a little bit dusty as for me. It wasn't rusty, I just brushed it a couple times and it looks nice and neat as for me. After that, I didn't even pay attention on this area anymore because, I mean, it looks good. Also another sticker which was here, and I already removed it so it doesn't disturb for the diagnostic. It was, if you see a circle over here, so here was another sticker. It was pointing somewhere over here also. I'm not sure what it was pointing. As for me, everything looks nice. Our card is up and running, and as always, I already did play games for a couple hours with it and already run a lot of stress tests. So far it's holding up. In a GPU-Z, how we can see, driver been installed perfectly fine, and it's complete 1080. How we can see by characteristics. And let's just run together stress test. It's holding okay, I'd say, and how we can see, there is a temperature increasing pretty smoothly, and I expected it to be a little bit more noisy, so it's pretty calm card. Thank you for watching as always. Please put likes, dislikes, subscribe for more repairs, and put your comments below. Thank you very much. Bye.